Where are we doing? So guys, what we've looked at so far is we looked at three types of graphs. Now circles, I know I went through real quickly, but I just want to go through parabola, sine, and circles and just talk about the features. Now when you guys are actually doing your graphs assessment, what you'll need to do is not only should you fit the graph properly, but also write down some properties and features of the graph, all right? And that's what we're going to go through. Stuff that's, I think we have done like little things of it already. It's just a matter of putting it all into words, that's all right? So just give me 1 second and we'll get started. Okay, so the first thing we're going to look at is, we're going to look at a parabola, all right? Now we know the equation for the parabola is y is ax minus h squared plus v, all right? The first thing that you guys can actually talk about is the vertex, all right? This is actually one of the properties or features of the graph that you can actually talk about. The vertex is at HV. Now don't write HV, all right? But you got to actually write it down as whatever the graph is. So for example, on the side here, I'll show you guys parallel what this would look like. So let's say this has a vertex at 2, 3, and the equation is y equals to 2x minus 2 squared plus 3. Then what you would write is vertex is at 2, 3. Okay, so that's like your first thing. Now if your parabola is looking like a smiley face, if it's a smiley face, then you say that it has a minimum point. It has a minimum point at HV. So in the example that I given you guys, it would be the parabola has a minimum point at 2, 3, because that's the lowest point of the parabola. Okay? Now if it was upside down, like if it was a happy face, like this, then it has a maximum point. All right? At HV again. So already there, we've covered a couple of like things that you already know. You already know what a vertex is, and then it's just a matter of saying where the minimum and the maximum point is. Okay, third thing. Every parabola is symmetrical, which means it has an axis of symmetry. So you can say that axis of symmetry is when x is equal to h. Now what I mean by that is right here in the middle, like it's like a mirror line for the parabola. So the red line is the mirror line, and then at that red line, so you can see this red line here, the x value is 2. So we're going to say, for the example I've given you, axis of symmetry will be when x is equal to 2. Okay? And the last thing for a parabola that's really worth noticing is the a value. So in this case, the a value is 2. So you can say something like this. Since a value is 2, the parabola will be, I think, skinny. Because remember we talked about that before? Like you have like really wide graphs, so you get like really skinny graphs. And that was something that we talked about right at the beginning. So if a value is bigger than 1, then it will be, the parabola will be skinny. But if a value is between 0 and 1, then it will be very wide. And if a value is negative, then it looks upside down. Okay? So that is something that's worth remembering as well. So for each graph, you need about 2 features. Ideally, I say to you guys, just give as many of the features as you can, because you guys can just keep writing about it, that's all. The fifth one is you can actually say horizontal movement and vertical movement. Now, this is very standard for all the graphs that you do. It's a standard thing that you can actually write about. So you can say the parabola has shifted. Now, guys, I know I'm writing this down, but like this is available for you later on as well on your notes, the whiteboard that I shared with you. So you can talk about it like this. The parabola has shifted h units right and v units up. Now, here's the thing though. If h is positive, then it's right. Because you know how it can also, the parabola could also move down as well, down and to the left as well. So just have a look at where your parabola is and then make the comment from there. So, and then I'd say compared to the origin. So origin is at 0, 0. So all you're saying is like, so in this example, you know how I had the parabolas right here. You can see this is at 2, 3. So that means it's moved 2 units to the right and 3 units up. That's all you have to say. I think that's most of the features for the parabola. Can I move to the sine curve now? Okay. Right, is there anything else? Vertex, axis of symmetry, minimum, maximum, shape, and then shift. Yep, that's cool. If I miss something, I'll add it on to you guys later on, all right? So, okay, so the next one is looking at a sine curve. Now, we know the sine curve equation is a sine 2 pi over p. And as usual, I'm going to give you guys an example so we can kind of see how both of them actually look like. So let's say this graph is y equals to 10. Okay, so that means this point right here is 5 and 6. Now with the sine graph, there's only few things you can actually talk about. The first one, the first feature you can talk about in the sine graph is this. You can say the amplitude for the sine graph is A. So in the example, I would simply write it as the amplitude for the sine graph is 10. The next thing you can talk about is the period. The period is P. So for our example, we write the period is 40 units. And again, we talk about that horizontal shift and the vertical shift again. So that's the third thing you can talk about. Now, I'm not going to repeat myself, guys, because that's what we did for the parabolas. So in my final answer, I can say the graph has shifted. I go back to this. I'm going to put this in a bit of a highlight the colors so you guys can see where that 5 and 6 comes from. So 5 units to the right and 6 units up. So if you look at it, this is where the 5 and 6 comes from. If it's negative, it's the opposite direction. All right? If say instead of positive 5 and 6 there was a negative 3 and 2, then it'll be 3 units to the left and then 2 units up. So that's just something to keep in mind. That's all you need for sine graph. Okay, and I'm going to give you guys the last one that we did. And I know we kind of brushed through it real quickly because in all honesty, we'll just do a bit more practice on that so we can get the hang of circles as well. Okay, so the final one is circles. So with circles, you know that the equation is x minus h squared plus y minus v squared equals r squared. So there's only two couple of things you can really talk about here. 3 things, but 2 of them are kind of interlinked. The first one is the radius of the circle is r. Now be very careful, guys. This is r squared, all right? And I know a lot of you guys were making that mistake, but this is only r. Okay, because it is radius squared, but the radius of the circle is just going to be r by itself. The second thing is the center of the circle. So you can say center of the circle is at h and v. So let me give you an example, quick example here. So let's say this is -3, -2, and it has a radius of 10. So then I would say radius of circle is 10. Number 2, center of circle is at -3, -2. Now, also remember, we can actually talk about the horizontal and vertical shift. And remember, these are 2 negative numbers. So that means you can say the circle has shifted 3 units left and 2 units down. And I got those 3 and -2. That's what happens to it. Okay? So when I give you guys your task, you're going to have to come up with the graphs. But after you come up with the graphs, you just need to write out some of these features. All right? And the last thing, remember that we did a bit of domain and range on Thursday, but we're going to do more work on it this following week. And that could also be counted as some features as well for the graph. So I'm just giving you guys everything you need to know. And remember, this is an open book test, so you guys can just access this information. That's why I didn't want you guys, if you want to copy it down in your own words, that's fine. But if you want to use my notes, that's also fine as well. But just, we're going to keep working on those features. Okay, so let's see.